Dear students, good morning. So today we'll continue the macromolecules. This is the second lecture under paper 2. So in the previous class you have studied the polymers, types of polymers and types of polyreactions. Is it? So under polyreactions there are two types. One is addition polymerization reaction, which is also known as chain growth polymerization reaction, and the second one is condensation polymerization reaction or step growth polymerization reaction. Okay, so under addition polymerization reaction already you have studied two examples. So one is polyethylene and the second one is polystyrene. So in both the case you have seen where the monomers are added with one another. So during the polymerization reaction there is a successive addition of monomers through the unsaturated valencies, so thereby getting polymers, that means macromolecules. Is it? So now under the same type of reaction or the polymer, addition polymer, the third example is polyvinyl chloride. There are totally four examples they have mentioned. Say first one is polyethylene, second polystyrene, third one is polyvinyl chloride, and the last one PAMA. Okay, polymethyl methacrylate. See, polyvinyl chloride is once again a macromolecule or a polymer in which vinyl chloride is a monomer. Vinyl chloride is a monomer. When the monomer is subjected to polymerization in presence of H2O2 or benzyl peroxide, so temperature range 30 to 80 degrees centigrade, in inert solvent media you will get polymer, that is PVC, polyvinyl chloride. Is it? So now here the monomer is an vinyl chloride, which is an unsaturated monomer. Even in polyethylene, ethylene is a unsaturated monomer. Even here also polyvinyl chloride, in polyvinyl chloride, vinyl chloride is an unsaturated monomer. So now it is necessary to know the preparation of vinyl chloride. There are two methods. In the first method, when the acetylene is made to react with, say, dry HCl in presence of mercurous salt as a catalyst and in the range of temperature 60 to 80 degree, so we will get vinyl chloride, that is CH2 double bond CHCl. Okay, so there is a second method where dichloroethane C2H4Cl2 dichloroethane, when it is heated in the range of say 873 to 923 Kelvin, then dehydrohalogenation takes place and as a result vinyl chloride will be formed. Okay, so now in both the case vinyl chloride is obtained. Okay, and now when this vinyl chloride is subjected to polymerization, it gives a macromolecule, that is polyvinyl chloride. So usually here it follows free radical addition polymerization reaction mechanism. So but vinyl chloride polymerization follows 80% suspension polymerization. That means where the vinyl chloromonomer, vinyl chloride monomer plus water is subjected to heating. Okay, and that is said to be suspension polymerization, and 12% emulsion polymerization and 8% bulk polymerization. Okay, and thereby you will get the say polymer. Okay, so now with this we'll go through the nature. So the based on say types of PVC, there are two types, rigid and flexible. So that means rigid, which are say quite they are white and solid, brittle in nature. Flexible So from the PVC, one can prepare flexible PVC by adding plasticizers. That means polymer compounding. It is said to be a compounding of polymers. When to the PVC resins, when you add some plasticizers, you will get a flexible PVC. So mainly there are two types of PVCs are using or they are in use. They are said to be a rigid PVC and flexible PVC. So they are chemically inert. They do not catch flame that easily. That means they are having a self-extinguishing character. Even it catches the fire, but it itself will get shut off. That means it will not continue of burning. So that is it to be a self-extinguishing character, and they are high strength thermoplastics. Okay, based on, and they are waterproof in nature. So based on these characters, used they are widely used in the day-to-day life. For example, in constructions, they are used as, say, in the form of, say, pipes, doors, window doors, and etc. And they are also used in making ID cards, bottle caps, or in making bottles, and flooring tiles, or in making helmets and hand gloves. And also they are used in making, say, mud guards. In automobile field, they are used to make, say, mud guards, etc. And they are the soft, say, flexible PVC usually used in plumbing, electrical cables, and sewage pipes, TV parts, tires, sports bags, hand gloves, etc. And they are chemically inert, so hence they are used in making, say, chemical storage tanks. And also in, say, medical field, they are used to make many medical instruments. That means parts of medical instruments or devices. And also they are used in making blood bags, etc. So it has got a many number of, say, applications or uses. Okay, so with this we'll move on to the next one, that is PAMA. So PAMA is nothing but it is a polymethyl methacrylate. Polymethyl methacrylate. Okay, and in this case, methyl methacrylate is a monomer. When this monomer is subjected to polymerization in presence of peroxides as a catalyst or initiators, it gives PAMA. And this PAMA is also known as acrylic glass or flexiglass. So PAMA is also known as acrylic glass or flexiglass. Okay, now here also it is necessary to know the preparation of monomer. So in this case, acetone is taken and it is made to react with HCl, hydrogen cyanide, and it gives the acetocyanohydrin. Okay, and when that is subjected to, say, when it is heated with H2SO4 and then, say, CH3OH, so it gives methyl methacrylate. So during the formation of, say, MMA, that is methyl methacrylate, this step follows dehydration. First it follows hydrolysis, then dehydration, then, say, esterification. Okay, so thereby it gives the monomer, that is MMA, and on polymerization it gives macromolecule, that is PAM. Okay, so now the properties of this compound. Once again, it is a thermoplastic resin and which has got a wide range temperature during the change of rigid nature to viscous. That from to change the physical state from rigid to viscous, the temperature range, it is slowly changes. So it is one of the main point or the property to use it in many fields. Okay, and it has got high optical transparency. So clarity is very more, that means very high. It is more than that of glass. So it has got high optical transparency and it is heat resistant, and also it is an insulator. Almost all polymers are having, say, almost same type of properties. They are chemically inert, so waterproof, quite stable, okay, weather resistant, heat resistant, and even say they are the good conductors of, say, sorry, they are not the good conductors, but they are the good insulators, etc. So especially pama, which due to its high transparency nature, so which allows 92% of the light, so which is better than glass. So, and also it has high refractive index and lightweight, thermoplastic. So based on these properties, they are used in optical devices, in making lenses, contact lenses, okay, and also they are used in, say, aircraft windows and artificial jewelers and headlight covers and transparent domes, skyless covers, screens of TV, say television, mobiles, smartphones, laptops, etc. Okay. So with this we'll discuss in the next class. Okay, thank you.